All right. So what we got here is we got a related rates problem that involves lamps casting shadows.
Right.
So it says a 1.5 meter tall man walks away from a 6 meter lamp post at a rate of 1.5 meters per second. Oh boy. So okay, so I'm not even going to finish reading the problem. I'm going to draw a picture to help me understand what's going on here. So okay,
Okay.
so we've got this
Lamppost.
lamp here, and so this is the lamp post, and so yeah, no, there's my light bulb at the top, and and the problem says that it's 6 meters. Okay, and I'm not getting any indication yet that that distance is changing. So I think it's safe to put a 6 there. I can always erase it if I need to. And then let's see, then we have this man who is 1.8 meters tall. Okay, so I guess there you go. We'll draw a little man, a little person here. And okay, and it said that that person is 1.8 meters tall. And they are, I'm assuming that's not changing, so it's safe to put a number there. And let's see, and it says that they're walking away from the lamppost. Okay, okay. So I'm going to indicate that with a little direction arrow under the person that says 1.5 because that says they're walking away at 1.5 meters per second. So okay, so already now the idea is I can see that there's a distance here that's probably going to be important. So I'll highlight it in red. This distance right here, the distance from the person to the base of the light pole, that is a distance, and it's changing. And so I'm going to go ahead and give it a variable name. I'll just call it X. So you can see in the picture that X represents the distance that the man is from the light pole. And if I want to go even further, I can note that the problem is telling me that dx dt is equal to 1.5, because that's what this arrow is saying. This arrow is saying that this distance X is increasing at a rate of 1.5 meters per second.
Okay.
All right. So we got that, and then now I think yes. So this is actually really interesting. That one sentence contained all that information. So yeah, this is why reading comprehension is so important. That just one measly sentence is worth, what do they say? One sentence is worth 1,000 pictures. No, that's not what they say, but it's worth a lot. So, okay, so anyway, okay, the light at the top of the post casts a shadow in front of the man. Okay, so that's weird. But here's the way I'm thinking about this. Yeah, so the light beam is coming down here, and it hits the man. And so there's all these light beams here, but those are all getting blocked by the man. So this is all the so what am I trying to say? Well, let me just finish drawing the stupid picture. So the idea is the light continues out there. So this part here, which maybe I'll highlight in a different color, this bit right here, this is the shadow. This is going to be the shadow that's cast, because light beams that are above the green line are going to hit the ground, but light beams that are below the line are going to get blocked by the man. So okay, so I guess I'm going to get rid of this because it's in the way. But what we got here is we got the shadow, and so okay, so and I guess Okay, so let's see what we got here. So it says, how fast is the head of the shadow moving along the ground? Oh, interesting. So, okay. So, all right. So the idea is, I guess there's another variable here. So I'll call this whole distance, I guess I'll call it S for shadow. And although it's not really the shadow, I mean, the shadow is just this little bit, but I need to give it some name. So I'll just call it S. And so our goal is to find ds dt, because that we want to find the rate at which the tip of the shadow is moving. So we want to find how fast is this distance increasing. So the goal is to find ds dt. Okay, so I think that's what we need here. So all right, so let me see here. Wait, will this pause? How do I pause recording? Oh, okay, so we've got the problem set up here. And yeah, so now what we have to try to do is write down some equations. So I want to write down equations that relate the changing quantities. Yikes. So what do I know? So yeah, ugh. So what's changing? So we've got X and we've got S. So I have to think about this for a minute. Oh my gosh, yeah, this is really tricky here. So yeah, so okay, what I want, okay, so let's be clear. What do I want? I mean, I want an equation that has X's, I'll put it in quotes here. It has X's and S's. I want an equation that involves X and S, because those are my changing quantities.
Right.
But it's not at all obvious what equation that's going to be. And so here's the secret, I think, is always be on the lookout for geometric objects. So when I look at this problem, I see triangles. And in fact, I see two triangles. I see the big triangle that involves the lamppost and the tip of the shadow. But there's also a little triangle here that involves the man and the tip of the shadow. So, and those two triangles are related because they're similar triangles. Since the smaller triangle kind of lives inside of the bigger triangle, those are similar triangles. So just for a minute, let me put, well, no, actually, no, wait. Wait. No. Sorry. I gotta just close my mouth when I don't have something to say. So since we have similar triangles, we know that the ratios of corresponding sides have to be the same. So let's write down what that means. So the vertical side of the big triangle is 6. Oh, sorry. So I'm using similar triangles here. The vertical side of the big triangle is 6. And the horizontal side of the big triangle is S. So that's the ratio of the two sides of the big triangle. And now let's look at the ratio of the two sides of the little triangle. So the vertical side of the small triangle is 1.8. And the horizontal side of the small triangle, the horizontal side of the small triangle is, uh-oh, I don't know what that is. And okay, so there's two ways you could proceed here. One way is you could put in a variable. I mean, you could like call this y, but I would not recommend that. I mean, it's not wrong, but the problem is it's introducing a new variable that we don't really have any information about. And so that's going to make our life complicated. So a much better idea is to think, is there any way to figure out what this distance is using s's and x's? And if you think about it, you think that you actually can, because S is the entire horizontal distance here. And then if I take away the red distance, then I'll get the shadow length. So this, if you think about it and you kind of stare at the picture, that this distance right here is S minus X.
Yes, it is.
Yeah. So yeah, so doing geometry is always usually pretty important in these problems, you know, kind of staring at the picture and just scratching your head and eventually something falls out. It's like solving a puzzle. All right, okay, so now the fact that these are similar triangles means that these two equations are equal, or not equations, these two fractions are equal. So now I'm happy, because we wanted to find an equation that involved s's and x's, and we've got it. So now normally what we would do is we would find derivatives of both sides. But before we do that, remember that once you have your equation, you can always simplify it before you find derivatives. You know, once you have one equation, any simplification that you do to it is still a legal equation, and it might be easier. Because if I wanted to find finding the derivative of this would be hard because it's got fractions. And so it'll be easier if we do a little bit of algebra first. So whenever I have one fraction equal to another fraction, my favorite thing to do is cross multiply, because that'll get rid of the fractions. So that's a pro tip there, that whenever you have a fraction on one side and a fraction on the other side, of an equation, you can always cross multiply and it'll get rid of the fractions. So 1.8 times s makes 1.8 s, and 6 times s minus x is 6s minus 6x. All right, and so yeah, so now this is much nicer. Finding the derivative of this is going to be 10 times easier than finding the derivative of this. So that's a good tip there. What do they say? An ounce of algebra is worth a pound of suffering with the derivative or something. All right, so now what we're going to do is hit this with a derivative with respect to t. And again, when I say hit it, I mean the entire thing. So the derivative of 1.8s is, well, what 1.8 is a constant, so it stays there. And the derivative of s is just 1, but not so fast. S is not t, so we need to put in a ds dt. And then the other side of the equation is going to be, well, it's pretty much going to be the same stuff. The 6 is going to stay there, and the derivative of s is 1, but s is not t, so you have to multiply by ds dt. And then we have to subtract. And again, the 6 just stays there. And now we have the derivative of x is 1. And oh, and this is where I have to maybe be really careful, because we're usually used to working with x is usually the independent variable. So, the derivative of x is just 1, but x is not the independent variable. So even though x is usually the independent variable and we don't have to worry about it, in these problems, x is not an independent variable. X depends upon t, so you have to multiply by a dx dt. Okay, all right, so now we're cooking, and now we can plug in the things that we know. So I know that dx dt is 1.5 because the problem told me that. And I don't know what ds dt is, but that's okay because I'm not supposed to. That's my goal. Oh, and here's ds dt over here again. So I have 2 question marks. So yeah, so actually, so it's still, it might be worrisome. Oh no, you got 2 blanks, but it's no big deal because we can just combine them. They're the same well, I'll show you what I mean. So algebraically, these 2 things will combine. So let's see what we have. So yeah, why don't we go ahead and this guy right here, let's do a little bit of algebra. Let's subtract this from both sides. So we'll subtract this from both sides. So what that'll do, what color am I at here? If I subtract this from both sides, well, I'll have 1.8 ds dt. I mean, and again, here, what I'm doing might seem complicated, but it's not really. That you could just think about this as a variable. Like you could pretend this is q, the variable q. What would you do if you wanted to solve for the variable q and you had a q here and you have a q here? Well, you move all the variables to one side. So you would try to move all the q's to one side. And so that's what I'm doing. That's all I'm doing here is I'm moving all the variables to one side. So, all right, so I got I'm subtracting this from both sides. So it's ds dt. And then the other side should just be a number. Yeah, 6 times 1.5, that's 9. So 6 times 1.5 is 9. So yeah, so I just have a nice easy 9 on that side. And now you can see what I meant by these will combine. Now I can factor out the ds dt. So I can factor the ds dt out. And what I'm left with is a 1.8 subtract 6 is equal to 9. And again, our goal was to solve for ds dt. And so now we're pretty much done because all I need to do now is divide both sides by this number. So we've now got that ds dt is equal to whatever it's equal to, 9 divided by 1.8 minus 6. Uh-oh, I'm worried. Why am I worried? I'm worried because this number is negative. That is it. Wait, yeah, the shadow did. Let me think about this. Pause it. Okay, so yeah, so I was really worried because again, this falls in the category of it's really important to check your answer. That I was seeing my answer. So let's be clear, my answer is wrong, but it's only wrong a little bit. We'll fix it. We'll be able to easily fix it. But I felt like this was wrong because this is a negative number. And the reason it's negative is because if you look at the denominator is obvious, sorry, the numerator is positive. But the denominator, I didn't simplify it, but the denominator is pretty clearly negative. And so a positive divided by a negative is a negative. So I got a negative, but if I think about the situation, I'm not sure that really makes sense. As the man walks away from the pole, should the tip of the shadow be moving towards the pole? That doesn't make sense. The tip of the shadow should be moving away from the pole, and that means that the distance is increasing. This ds dt should be getting, this s should be getting bigger. So the fact that this is a negative really freaked me out. But I see I made an algebraic error here. It's right here. See this negative sign? That was -6 times 1.5. So if you notice that as I was doing the video, you probably said, no, Travis, you're making a mistake. So anyway, so that should actually be -9. And so this is a -9 now. And now we have a negative divided by a negative, which is a positive. So that's much better. Oh, and that actually, and that's another pro tip that sometimes, I mean, this isn't super reliable, but you probably noticed it from doing your homework. Sometimes if your first answer doesn't work and you look at your work and everything looks pretty good, just try flipping the sign of your answer. I mean, it's a gamble because it doesn't always work, but a lot of times, at least for me, I make a mistake with a minus sign somewhere. And so I just wind up with the negative of the correct answer. So if I just flip the sign, if the computer says I'm wrong, but it seems like everything I did was right, if I flip the sign, then it'll fix it. All right, so there we go. So that was a tricky problem.